Hello everyone. Today I'm back with another example. So we need to determine the output of the this network. So the given input is a sinusoidal wave with peak amplitude 20 volt, and there is a voltage source of 5 volt, and there is a diode. This is an ideal diode as nothing is written here, silicon or germanium, and there is a resistor. So we need to determine the voltage across this resistor. So first we will do analysis for the positive half cycle from 0 to t by 2, and then for the negative half cycle. So in the positive half cycle, both the source are forward biasing the diode. So the diode can be replaced by short circuit. Now if we can observe, this is the input and this is the voltage source. This is the voltage source. Now these both are forward biasing the diode. That means the current established because of this voltage source will be in this direction, which is matching the arrow of the diode, and the current because of this 5 volt source will also be in this direction, which is matching with the arrow of the diode. So we can replace it by a short circuit. Short circuit means by a 0 volt drop. So it will happen from 0 to t by 2 in the first half cycle. So now this is how we will replace the diode with a short circuit, and we will apply the KVL in this network. So applying the KVL in the network, Vi plus 5 volt minus 0 volt drop minus V naught is equal to 0. Now this is the KVL equation, and after solving we get the output voltage V naught is equal to the input voltage plus 5 volt. That means the output will be shifted by 5 volt upwards. Now let's see the output at when input is 0, which is 5 volt, and the output when input is 20 volt at the peak, and it is 25 volts. So what happens in the output waveform is the waveform will be shifted upwards. As you can observe here, the waveform from 0 to t by 2 in the first half cycle, it will start from 5 volt, reach 25 volt, and again reach 5 volt. It is just shifted by 5 volt upwards. Now this is about the first half cycle. Now let's see about the second half cycle or the positive half cycle. Now during the negative half cycle, what happens is, in the negative half cycle, the circuit diagram is like this. So we change the polarity of the input. In the negative half cycle, the polarity of the input is changed, and we can see that the voltage source is trying to forward bias the diode, and the input voltage is trying to reverse bias. But magnitude of voltage source will be dominant till input becomes 5 volt. Now what is this? Now what is this section is telling about? Now we can see that the current established because of the input will be in this direction. Let me change the color. And the current established because of this will be in this direction. So one is, this current will be coming like this, and because of the this voltage source the current will be in this direction. Now it is, so the current due to this voltage source is matching the arrow of the diode. So this is trying to forward bias, and the current due to the input is against, or it is opposite to the arrow of the diode. So it is trying to reverse bias, or it is trying to off the diode, and this is trying to on the diode. Now when it will on and when it will off. So here the input voltage, now let's read this sentence here. Voltage source will be dominant till input becomes 5 volt. That means the voltage source of 5 volt will be forward biasing the diode until the input voltage becomes minus 5 volt. Now now how we can say that till input voltage becomes minus 5 volt, the diode is in on state. Now for that, for determine the That transition, that means when the diode is going from the on state to off state, there is something called as a transition where the diode will enter into off state from on state. Now to determine this transition where it is happening, what we need to do is we need to open circuit the diode and replace the current with zero through the diode. So open circuit voltage and the current to the diode is zero. Now let's apply the KVL. By applying the KVL, which is 5 volt minus V open minus 0, because no current is flowing through the circuit, so minus 0 volt, this V naught will be 0 volt, minus VI, this one, we are going like this, is equal to 0. So 5 volt minus VI is equal to V open. Now we are sure that when V open is positive, the diode is in on state, and V open is negative, the diode is in off state. So when does the V open become positive and when does it become negative? So V open will be positive until Vi is equal to 5 volt, and V open is negative when Vi becomes more than 5 volt. Now this is what it is saying. Until V open is positive, the diode is on. So when the input crosses the 5 volt and increases more, the diode becomes off, that is it becomes more than 5 volt. Then more than 5 volt, the diode is off. Now now please don't confuse why I have said minus 5 volt over here and 5 volt over here, because I'm talking about the magnitude, not the sign. I have already changed the input, the polarity of the input. So when we change the input polarity while writing the KVL equation, we just need to take the magnitude. Now we have changed the polarity over here. Here it is minus plus and here it is plus minus. When you have changed the polarity, you just need to take the magnitude. If you haven't changed the polarity even the second half cycle, then you can take the input voltage to be negative. That's a confusion which will arise when applying the analysis in the negative half cycle. Now we have seen that the diode is on till input becomes more than 5 volt. So for the positive half cycle we have determined, and look, this is the input. Until when the input reaches 5 volt, the diode is on. When the diode is on, it is conducting. So when it is conducting, so we can use this equation when the diode is on. Even in the negative cycle we can use this equation until the input becomes more than 5 volt. So according to that equation, so here the input, so here the input is say -1, -2, -3. You will be substituting those values in this equation. Substitute values in this equation until input becomes this minus 5 volt, minus 5 volt, or you can say magnitude wise 5 volt. We will get this, sort of waveform. And when the input crosses minus 5 volt, or it becomes more negative than minus 5 volt, the diode is off. When the diode is off, no voltage across the output or across the resistor, so no voltage, 0 volt drop. Now you need to understand this part is very crucial. You can obtain this part from the above equation, which is V naught equal to Vi plus 5 volt. So when you go on substituting the values of the input, you will get the output until here. And when you join all those, you get this sort of waveform. Now that's it for this video. Thank you for watching and subscribe my channel.